Hello, third grade. Hope you had a great Easter weekend. And I just want to let you know the things that you're going to need for today's video. You're going to need your Star Master Quick Review book. All right, so if you don't have that and a pencil, go grab it. Okay, and we're going to go ahead and get started. We're going to be on page 60. So let me underline that for us. So page 60. And on the page that we're doing today, we're going to concentrate on using strategies. Okay, so that's something that even if we can't meet together, that I'd like for you to make sure that you're always doing on every math problem. And so we want to stress that for this whole time. So if we're going to start, I'm going to look at number 1 on page 60, and the first thing you do is you just read it. Try to understand what's happening. It says, Mitzi has 18 goldfish, 12 tetras, and 9 guppies in her fish tank. Okay, we understand that. How many fish does she have in all? So we go back and we use our strategy, our cube strategies, which tells us that we need to circle our numbers. And we need to notice what those numbers go with. I could have circled goldfish with that, but I'm just going to underline it in mine. So if you circled it all together, that's great. Okay. And then we have 12 of the tetras and 9 guppies. And I make sure that when I'm circling, I don't mark out anything so I can't read it. Make sure I'm doing it neatly. Now, we have our question. Some of you underline the whole question. I don't do that. I only underline or box, usually, the action words that tell me what to do. So if I said, how many fish does she have in all? So I know my answer has to be fish because they're wanting to know how many. And then there's a key word in here, or 2 key words. When you put them together, they're the action words, or the things that are going to tell me what to do. And it says, in all. Do you remember when we had those exercises where we'd stand up if you add and subtract, you would go down? Well, in all was one that we stood up. So that means that what operation will we be using? We're going to use adding on that. Okay? Now, I'd like for you to set up this problem. There's all different ways that you could set it up, but I'd like for you to set it up, work it out, okay, and then start the video. So right now, pause, work this problem out, and then turn the video back on. Did you get it done? Let's look at our answer. We've practiced in our math lab being able to add 3 numbers in a row, and some of you even have made it up to adding 4 numbers in a row and really big numbers. So this shouldn't have been much problem. When we're looking to add, remember, when you're adding a whole column of numbers, look for sums of 10 or doubles. And so I noticed 8 and 2, that's a sum of 10, or they add to 10. So 8 and 2 is 10 plus 9. Well, it's easy to add to a 10. You just say 19. I carried or regrouped my 1. I add it again. So our final answer would be 39. So 39 fish, right? And then you would just come, I need a fat marker for this, and then you just come in and you would color in your numbers there, all right? Now let's go ahead and look at the next problem. Remembering, we don't solve anything until we understand what we're doing. I'll read it. Which number could correctly complete both equations below? So I need a number that I can put here, and I need a number that I can put here, and my only choice is a 6, a 7, an 8, or a 9. So if I look, this is starting to look like, oh, I have an 8 here and a 56 here, but those same numbers are over here, but these are opposite operations. So they're probably in a family of facts. So I could draw a family of fact house like we've taught, or I've taught you how to do in class. Or I could just do a guess and check. I could put numbers in and see if they solved my problem. Or I might even know the answer. So if I were to come in and I were to say, think about this number 6 right here. 8 times 6 is 56. Is that true? No, not at all, is it? So let me pick myself up a pen here, a skinnier pen this time, and say, I know that can't be my answer. And I hope that you're keeping up with your multiplication. One easy way to do it is to ask your parents if they can get one of those free apps like that you can get on a telephone, and just do that for about 10 minutes a day. It'll really help you with your multiplication tables. So you might, play a game with those and see how that works. But I know that 8 times 6 isn't 56. It's 48, all right? So if I come over here and I try the 7, 8 times 7, 8 times 7 is 56. And so I think that's probably my answer, but I want to look at the others too. If I were to put in 8 in this place, 8 times 8 is 64, so that can't work. And then if I were to put a 9 here, 8 times 9 is 72. So that wouldn't work. So I think it's a 7. Okay, so let's go ahead and place a 7 there. But does that work here? 56 divided by 8. And some of you might go, well, I don't even know how to divide. Well, that's okay. We could work this problem backward. 7 times 8 is 56. Yeah, that works. And that's what this was. So this was a family of facts, being able to decide which one worked. Okay, I should have X'd those out because we didn't need those, did we? So let's go on to our next page and change my pen color again. And we're going to be on page 61 this time. This one's a little more complicated. So if we look through here, let's read first. Mrs. John lives 26 miles from her best friend and 15 miles from her job. So we're given some information here, aren't we? After she moves to her new home, she will live 3 miles closer to her best friend and 5 miles farther from her job. Which number sentence shows how to find the number of miles she will live from her job after she moves? Okay, there was a lot of information here. So what I want to do is make sure that I understand the question. So I'm going to concentrate on the sentence with the question mark. And it says, which number sentence, and I notice that we have a lot of number sentences over here, shows how to find the number of miles she will live from her job after she moves. Okay, so that's after she moves. So, do I need the information, every piece, every number up here? Well, obviously not, because none of these number sentences has every number from up here. So I have to think through, okay? I know that she lives 26 miles from her best friend, but do we care about that in our final answer? We only want to know about the miles from her job. This happens to be a question that if you were to look at your cube strategy, there are things that it tells you on the E in cubes to get rid of something. And let me show you that real quick. And here it is. It says evaluate and eliminate. Well, this is a problem where we're going to have to eliminate some information. So I don't need to use any information that has to do with how far she is from her best friend. But I do need the information about the job, how far she is from her job. So at the beginning, she was 15 miles from her job. And after she moved, she's going to be 3 miles closer to her best friend. But we only want the job information. So I don't need the best friend stuff. And 15 miles farther, or not 15, 5 miles farther from her job. Now, if she's farther away, that means she's going to have to be more than 15 miles away. So am I going to add the 5 or am I going to subtract the 5? I want you to pause the video, think that out, and which choice are you going to make? A, B, C, or D? Make your decision and then turn the video back on. All right, did you decide? Let's look. Well, if we look over here, we can eliminate 2 of the answers because they had information about her being away from her best friend. We didn't want that. We wanted only job information, and that's why this was circled right here. So, if she's going to be farther from her job, do we want a number bigger than 15 or smaller than 15? I hope you chose bigger. If she's farther, she's going to have to travel more miles. So I would need 15 plus 5. Well, that makes 20. And we do have a problem over here. 15 plus 5. The reason we can't use this one, that would make her closer to her job. 15 minus 5 is 10. And that would make her closer, not farther. So our final answer is 15 plus 5. All right, see how I'm thinking through these problems? Now, let's go and see if we can go to our next one. And this will be our final one that we're going to work on in this book, but I'll have something else that I'm going to add to the video. So even after we've solved question 4, I want you to hang out because I'm going to talk about something else after the video, or after this number 4. So here we go. I'm going to go ahead and pick up another color of a pen. And it says, a store owner wants to replace the wheels on 6 tricycles. She will need 3 wheels for 1 tricycle, 6 wheels for 2 tricycles, 9 wheels for 3 tricycles. How many wheels will she need for 6 tricycles? Now we do our cube strategy, and on here we say a store owner wants to replace the wheels on 6 tricycles. And it goes on to tell us, it takes us through this store owner's process. 3 wheels for 1, I'm going to go ahead and put the number 1 there, for 1 tricycle. 6 wheels for 2 tricycles. 9 wheels for 3 tricycles. We're thinking through this. I could have even put a picture there. So hang on just a second and let's look at what a picture would look like. Aha, here we go. And now here's our picture. So this explains what went on. So for 3 tricycles, she would need 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's exactly what they tell us, okay? 9 wheels for 3 tricycles. But we need 6 tricycles. You could continue on with the picture, but I also want to show you another way that you could have done this. And this is called a T-chart. And you could have said, well, the number of tricycles, and I'm just going to put tri here, the number of tricycles, and then number of the wheels that we're going to need. So wheels and tricycles. And if we go for 1 tricycle, she needs 3. That's exactly what our problem told us. For 2 tricycles, she would need 6. For 3 tricycles, she would need 9. Okay, if you'll notice, we're building a table. And on this table, we could have just continued down and figured out the rule for our table. So here's another way that we could have thought through that. All right, is what makes this table work? Or a number machine like we talked about on some of our last videos. I'd go, what times 1 would be 3, or what plus 1 will be 3? Well, this happens to be one that I can see real easily. 1 times 3 is 3, and I know that that will work for the next one. 2 times 3 is 6. 3 times 3 is 9. And so our rule is times 3, or each time we get another tricycle, there are 3 more. Okay, so if I were to place I need 6 tricycles, so I'm going to put a 6 in the tricycle column. And I say, well, it worked for everything else, so it has to work for this. That's how a number machine works, or a T-chart would work in this case. Okay, and we'd say 6 times 3. You have to be pretty good at your multiplication tables for that, but we know that 6 times 3 is 18. Okay? And we could have also shown that in a picture. So see, there's a couple of different ways that you could solve this. This is solving with a table down here, and this would be, if I continued my picture, solving with a picture. All right, now, one last thing that I want to go over, and I've had some people ask about it. This is going to be our blank page, so all you'll be able to see is me in the corner for just a second. They've been asking about rounding. Now, I want to remind everybody about rounding. One of the most important things when we round is to know where we need to round. So I'm going to do a little place value chart here. And so we have our ones, tens, hundreds, and thousands. Most of the time, you're going to be told where to round. And let's say that we have the number 2,364. Okay. In this number, we might be asked to round to the nearest 10. When you're rounding, remember, use some strategies, use something to help you through it. And what I suggest and what we've learned and what I've taught in class is that we underline the place where we're going to round. So now I'm going to underline this number right here because I said I was going to round to the nearest 10. That means the power holder number, the number that'll tell us what we need to do, is right behind it. And most of the time, I ask you to put a dot under that number. So I've underlined the place value where I'm supposed to round, and I put a dot back here. And remember, we did that goofy thing where I said, okay, here's the magic wand, and this is like the tip of the magic wand. That was just a silly way to help you remember. But if your number is 4, 3, 2, or 1 in this power holder position, this number has to stay the same. If it's a 5, 6, 7, 8, or a 9, this number gets to go up. So our power holder, is it a 5, 6, 7, 8, or 9 that will cause this place value to go up 1 place, or is it a 4, 3, 2, or 1 where it has to stay the same? Well, it's a 4, so that tells us that this number has to stay the same. So our new number, we would drop below, and we would write it. This place stays the same. But then in rounding, we always remember that our numbers need to end in 0. Or when we talked about it in class, I said, okay, that's like your fairy godmother who had the power. Poof, she disappears. And so we made her disappear. So that was just our silly way to remember that. I hope that helped for some people who were having trouble with their rounding. Okay, I'm going to do this one more time real quick. Let me do a little erase here. Okay. I'm going to put our same numbers up. Let me change my colors here. And we had a 6 and a 4 back here. Okay. If we had Let me erase some of this extra stuff. It said, all right, you need to round to the nearest the nearest 100. What would you do then? You would underline the hundreds place. Your power holder would be just this one digit back behind it. Is it 4 or less? Same old number, or we used to say in class, same old dress. If you're thinking of this over here as your Cinderella, is this a 4 or less for the fairy godmother's power? That would mean this would be same old dress. Well, it's not. It's a 5 or more. So that gets to bump this number up. Or we might say in class, if you remember the Cinderella story I told, 5 or more dance up to the door in a brand new dress. So we would bring our same thousands place down. We were rounding to the hundreds, so that's the place that can either stay the same or go up. Gets to go up this time. And remember what happens to our power holder or our fairy godmother? If you're doing it my weird, goofy way, poof, and then the number 4 has to go poof too, because everything behind the fairy godmother goes away too. All right? So for some of you who had forgotten how to round, that's just a real quick refresher course on how to round. And, okay, if you wanted to try estimating on Study Island, you could use your rounding skills there. Estimating just means you take the numbers in the problem, you round them, and then you decide whether you're going to add or subtract those problems. Hope that helped. Hope you're still visiting Study Island. I know some of you haven't been as often as I would like, so maybe spend a little bit of time on Study Island this week and practice up on rounding and working through your math. Hope to see you next week and have a great week. Bye-bye.